Okay, so as I said in the previous module, towards the end of the previous module, we will look at key points of a good LCA, and I will go through this relatively quick because I think we have covered enough material in terms of the LCA methodology, and through the discussion of each of those slides and different modules, I have tried to give you a good idea about what should be goes into the good LCA exercise. But again, just a quick recap, this few slides you can use as a resource when you are trying to do some LCA activity. So that was one of the reason. That is also one of the motivation why to put these slides over there, which you can whenever you are doing an LCA activity, you can look at these slides and do your kind of checks for each one of those. So let's look at one by one. So in terms of the key points for a good life cycle assessment exercise, first thing, as you know, you have to have a screening approach. When we start with goal and scope, that's our number one. So a screening approach is, if you remember in the beginning, we said that when we do this LCA, sometimes we do it in 2 steps. In the first step, we will do a screening level LCA, and to get the order of magnitude results, where there we don't go into nitty-gritty detail, we just do a screening level LCA. And that what does that does it helps us to find out which are the processes which are having the bigger impact, and then we focus in the second detailed LCA, we refine the results and focus on the most contributors. The stuff which doesn't contribute much, we can ignore that, because as I said earlier, as you have seen earlier, it in terms of the inventory analysis, in terms of the different unit processes, things can go like in big tables. So to avoid having so much of data to deal with, we try to pick the data, and then what happens when you are looking at too much data, sometimes the important data gets ignored. So we are trying to focus on the important data for which we can get the results. So that's the screening approach. Then you go for the goals of the study. We already talked about that. Goal is very clearly defined, what for and for who. So that's the goal of the study we looked at. Then we found out the function and functional unit. Your starting point of defining the system boundary, you have to have the function, and the comparison is the basis of the same function. Secondary function, we have so far not got into that. The secondary functions for some initial LCA, I would say you can just ignore the secondary function unless the secondary function is also pretty predominant as the primary, very close to the primary function. Then of course you have to do the allocation. But for most part, for now, let's just focus on the primary function part. So starting point in defining the system boundary, you can do the comparison. Functional unit is the quantification of the function of the system. It's never a ratio. It's a quantification of the function of the system. Inventory is related to functional unit. So we have the inventory. We make the inventory related to functional unit. You saw that example. Then we have the reference flow. We talked about that. That's the amount of product provided per functional unit, different for compared system. Then we looked at the parameters in terms of the functional unit, reference flow, those optimization and all that. System boundary, all process need to provide the function. So rule 1 is your compared system must provide the same function. So when we look at the compared systems, they should have the same function. And then you include the processes or those which contribute more than a fixed percentage. We talked about that, what, 0.07% or something like that. In one of the initial slides we had that. So if it's a more than a fixed percentage in terms of the mass, energy, or environmental release cutoff criteria, then we include it. Otherwise we don't include it. Otherwise it gets too long. And if there are identical stages, processes between the compared system, we can exclude it only if it does not affect the functional equivalence. We talked about that. Remember that herbicide example, that herbicide A versus herbicide B, and we talked about this particular case in much detail. If you don't remember, go back and look at that particular module. That would be, I think, week 5, one of the first few module, first or second module, I don't remember right now, but it was there in herbicide A versus herbicide B when we did that comparison for when we can take an identical stage of processes off only if it does not affect the functional equivalence. Data quality, we already talked about a lot about that. Validity of the study depends on the quality of data. You have to have geographical, temporal, technological, uncertainty, primary data, secondary data. So those things are important. Multifunctional process, there are several approaches to treat multifunctional process. The results are often strongly influenced by the approach you choose. So here you try to basically, you have to do the allocation of different emissions as well as input as well as output for this multifunctional process. So you check, you do one approach, and then you test the robustness of the conclusion by applying other approaches to see which approach, how the approach based on different approaches, how the conclusion changes. After you are done with the inventory, you go for impact assessment, and it's done based on the goal and scope. Again, there are different methods out there. We only use known and peer reviewed methods. Right now, impact 2002 plus and recipe 2009, those are the important, those are more common impact assessment method which is used. You can use other methods as well, but then you should justify why, which method you are using and what is the rationale of using that particular method. And then you many times you should try to compare one method with the others in terms of that gives you the robustness of the conclusion as well. Then finally, interpretation, which you look at analyze contribution at different level at each phase of LCA, inventory, impact evaluation, each life stage, concentrating on main contributions and those with high potential. At the substance level, do the sensitivity analysis to find out your stuff. So that's in terms of what was like we can get a summarize of like a very quick summary, few slides, and that's in terms of key points of a good LCA. Again, those slides could be a handy document for you later on, where you can, whenever you do an LCA exercise, you can go and check whether you are doing it correctly or not. So that's to give you some idea and a kind of a ready reference. So in terms of LCA methodology, or what is an LCA, in terms of, if you can try to summarize that, although we are not at the end of the course yet, but we are in the 6th week, but whatever we have kind of covered so far, if you, it's always better to kind of, in my view, I like look, we always try to, once we covered some detail, it's always a good idea to kind of sit back and try to see the big picture, and then you go back and look at more detail. That's okay, but don't forget the big picture, because that's what it's very important. Many times what happens is, especially those of you a master's or PhD student, you get so much engrossed in your individual experiments as part of your thesis, as part of the research project, you don't really, many times in the interview, in the your exams or presentations, when we ask you the big picture questions, you are not able to answer that. Big picture means why it is all, whatever research you are doing, why you are doing that research, what new things you will learn from your research which will help your community. See, most of you who are doing research projects in India or abroad, wherever you are doing it, this research funding is coming from taxpayers' money. So this taxpayers, people like you and I who are paying taxes, or your parents or whoever is, those pay the taxes, that's money is coming back to you as a research projects. That's what funding for your master's stipend or a PhD stipend, or your PhD DST project, DBT project, whatever MOEF project that you might be working on. So there should be a you need to understand that this whatever research you are doing should have some sort of benefit to the society, because the society is paying for it. So you should not forget that, especially for engineers. I would say that since we are for engineers, it's true for anybody, but for engineers we should also, basic science we have to do, but at the same time we have to show that how this basic science, whatever we are developing, is going to be implemented in the real field, and what changes this will bring. So what was not there, which will be added by my PhD work or by my like a master's thesis work. So you should always look at the big picture, which students tend to forget, and they get so much engrossed into the details and the mechanisms of certain equations, certain reactions, certain things happening, where you, okay, those are very important. I'm not saying those are not important, those are important, because understanding of those is very important, but at the same time, why we are doing it, what we are going to get out of this, and what benefit it will bring to the society, which is not there, what new things we learn from this particular research project. Those things you need to really think about, and those are important questions that you will have to answer in any, whether in your PhD exam, master's exam, or even during your job interviews. They will ask you those kind of questions. So in terms of looking at the big picture, which I said is important to look at, so let's summarize what we have learned in terms of LCA so far. So what is an LCA? Is a it's a way of structuring and organizing the relevant parts of the life cycle. So it's a life cycle cradle to gate, gate to grave, and gate to gate. So there are different types of life cycle we can look at. So it's a way of structuring and organizing the relevant parts. So when we say structuring and organizing, with different unit processes that goes into that particular exercise, and it's a tool. Again, it is a tool. It is a tool to track performance and perhaps to improve product design. So we can use this tool to track the performance in terms of environmental footprint, in terms of the environmental performance we can track, and also help in improving the product design, to make it more environmental friendly. LCA is not a cure-all for all our environmental problems. So again, it's a tool which we can use to understand things better, to understand things from a systems perspective. But that doesn't mean that if we do LCA and if we don't do the follow-up study associated, follow-up task associated with this, whatever we learn, whatever is the recommendation as part of the life cycle interpretation, and if that thing is not followed up, things doesn't change, that's not going to do any benefit. So it's not a cure-all for all our environmental problems. So that's we need to be really careful. But many times what happens, anything new comes, everybody will do LCA. Say if LCA, once this LCA is getting popular in India, now you will see that even I will say globally, many studies they are doing LCA. They are doing, and sometimes I hear that, oh, these days publishing papers in LCA is much easier. I don't agree with that. But working in this area for a few years now, it's not easy. You have to really do a good LCA exercise to get it published in a good journal. Of course, there are a lot of I would say journals are out there these days. Publishing any paper is not a problem. You can there are some journals which will charge you certain money and publish that paper. But to publish in good quality paper, doesn't matter whether you are doing LCA or whether you are doing some other research. Good quality research is important. Again, so it's not a cure-all. Just do the LCA exercise. You publish this paper, and then that's it. That's put it in our CB, but that's not getting implemented anywhere. So, and it's not an exact science with provable axiom or theory. It's not an exact science. It's essentially is an accounting exercise. We are trying to look at all the emissions, input and output. We are trying to look at the big picture environmental footprint of any product or any process. That's what LCA helps us do it. So that's kind of summarize of all these, and then we'll look at some of more detail as we make progress, as we make further progress in this particular course. And towards the end, of course, we will again try to summarize, and then some of these things will come up for discussion too. So if you, as just now we finished looking at an LCA methodology, so let's look at an example of how LCA. This is a real example. This was a project done by a master's student working with me a couple of years back. So this particular product, it's an Enerpax, and I will explain you what this product is there. That we are trying to do a LCA of Enerpax from cradle to gate. So this is an example. Let's walk through this example so that you see how this goal and scope, function and functional unit and other things were used over here. What is LCA? You already know it, so we'll kind of just skip that. There are multiple approaches to LCA. You can do cradle to grave, cradle to gate, cradle to cradle. That's your whole life cycle. Gate to gate, well to wheel, and we'll talk about that later. So it's a tool where you can look at the environmental, social, economical, but mostly we'll focus on environmental aspect, and you already know about this life cycle assessment framework: goal, scope, inventory, impact and interpretation. So LCA is a technique to assess the environmental aspect. We already we compile inventory and relevant energy and material input. We look at the potential environmental impact associated with the inputs as well as the release, and interpret the data. So this project was done for a plant. It's called a Dongera plant. That's the name of the company. It is just outskirts of like main Toronto area. It's in Greater Toronto area, and it's located in Vaughan, which is in GTA, Greater Toronto area, and it processes municipal solid waste from Greater Toronto area and the regions of York, Durham and Peel. So when we say municipal solid waste in this particular area, these are all areas of Ontario and Southwest Ontario predominantly. That so they had most of these cities that have been listed over here. they have a three-way collection system. When we say three-way collection system, they have we are talking about municipal solid waste collection. So they have recyclable collected separately, wet waste going for composting or anaerobic digestion, wet waste means food waste and other organic, that is collected separately. And the third category is non-recyclables, non-compostables, like non-biodegradable, and I should not say bio because even third category may have some biodegradable waste, but non-compostable or going to anaerobic digestion, non-recyclable, that material is what this particular plant is processing. So, and it is producing it is a processing residential MSW as a feedstock to manufacture pelletized fuel product. So they were making some pelletized fuel product, and we did an LCA exercise. When I say we, like my student actually did it under my supervision, and that was part of his master's work. And that's we made a pelletized fuel product that came out of that. So it's a fuel product produced in Dongera. You can see the picture over here. This is how it looks like, a small pellets, and it contains an energy output of around 10,000 BTU per pound. So it's a lot. It's a good energy source. And around 60% of the incoming waste, since it's a non-recyclable, non-biodegradable material, the material that were coming to the this Dongera plant, not entire material had good calorific value. So whatever goes in here should have a decent calorific value. Then only you will have a good product. So that's they had, but they should be they were able to utilize around 60%. The rest 40% they were sending it to the waste to energy plant, which was nearby, and either depending on whether the waste to energy plant will take it or maybe it will go to the landfill, which was few. So what was the goal? Again, the steps. So goal, definition, and scope. So the goal of this study was to see the environmental impact of this NRPAX in comparison of medium grade coal. Now here you need to understand the background behind this particular project. So this was a project funded by this particular company, and because this company wanted, they were trying to apply to Ministry of Environment in Ontario to let their waste, this particular product, be used by coal-based thermal power plant. So this coal-based thermal power plant were using this medium grade coal. So that's why they wanted to compare with medium grade coal, because the medium grade coal is already used. The reason this product is coming from waste, many countries around the world, even the products making out of the waste material it's considered almost as good as the waste material. So unfortunately, that's to certain extent is unfortunate, but that's how it is. So there are the regulations in place right now. So for example, if when this particular project was done few years back, and based on the regulation that was prevalent on that particular time in the province of Ontario in Canada, what was there, that if you have this product, if you are going to use this NRPAX pellets, you are as good as a waste incinerator. So and for waste incinerators, the waste incineration plant, they have a stricter environmental control, stricter air pollution control system requirement as opposed to what is needed for like a coal-based thermal power plant. So here we compared the medium grade coal, since NRPAX had similar energy content as well, and that was being used in those coal-based thermal power plant. The analysis were performed from cradle to gate. So cradle was when this municipal solid waste coming, that was to the plant, and to the gate once the NRPAX is going out in terms of plant as a product. So the combustion property information of NRPAX were unavailable to perform cradle to grave analysis. So that's why we used cradle to gate. The chosen function for analysis is providing energy, isn't it? That's what both the cases we are providing energy through combustion. Therefore, we choose a functional unit of 992 giga BTU was selected, and because that gives a total input of around 75 tons of MSW. So out of 75 tons of MSW, we will get around 992 giga BTU. So that's what was chosen to compare both NRPAX as well as the medium grade coal. So this was the process flow and the boundary layer. So this is the MSW being picked in the curbside. The truck transport goes to the facility in terms of the manufacturing, and there was some electricity, some fuel will come, and then some recycling of the waste coming out. Some of the waste will come out which will go to the landfill, some of the recyclable can go again to the recycling center, and the product, it goes to truck transport to consumer, then it can go another truck to the incineration plant. So these are, so that the red dotted line is what we have chosen for this process flow or the boundary layer for this particular waste stream. So there was, as I said, there will be always certain assumptions and limitation. So here the facility was assumed to be a black box because only inputs and outputs considered. We didn't had data for other details in terms of individual process, like material or energy input from individual process. So we assume 75,000 tons of MSW annually processed as Dongera, and then again assumed waste was strictly coming from region of York in terms of calculating the transportation requirement. Average distance travel was 41.4 kilometer, collection truck capacity is 18 tons. So think about that. You have to make certain assumption. You cannot really, that's the nature of the exercise is such that you will have to make certain assumptions, and then if two different people are making different sets of assumptions, the results will be different. So but then you need to make it more as any assumption you make, you should have a strong basis for that, so that in that case it will be other people will have a, if everybody follows that particular principle, the assumptions will be similar. So coal production scenario, like cradle to gate analysis for the coal as well, only the production of medium grade hard coal briquettes. So here we assume the total MSW sent to incineration, distance travel in transportation is identical to that in NRPAX plus LCA. So that's so we also looked at the incineration scenario, that's part of that. So in terms of MSW breakdown, these are the different percentages. These are organics, plastic film, paper and cardboard, wood, hard plastic, glass, metal, PVC, and non-combustible. So although it says this is what coming into the system, and this we got, this was actually came from one of the study earlier done in terms of what is the percentages of the waste that comes in, and then out of that there are certain material gets rejected because it cannot be used, and then rest is used in NRPAX material, and the other stuff which cannot be used just goes off as a waste material, either to recyclable or for example glass, metal, they can be recycled. Even hard plastics, HDPE could potentially be recycled. So but then NRPAX doesn't uses that. NRPAX only use part of these, and so that's our and what is there in the organic fraction of the waste. We had some food waste stuff, textile, rubber, yard waste. Some metals had aluminum, paper and cardboard. Paper was there in terms of waste paper, cardboard. So those things were present in terms of what was there in terms of MSW breakdown. So the rejected waste, plastic film, hard plastics, some of this rejected waste could be recycled, some will go into the landfill. So that's what. So in terms of after doing this LCA exercise using NRPAX at Dongera, LCA scenario for coal and LCA scenario for incineration, what we found, and this is this kind of graph that you get from when you look at some of these data. This is again coming from the CIMA Pro software. This is what you get, this kind of graph. So here, if you look at those categories, these are as I said earlier, we'll make one total comes out to be 100, and here you have different impact categories in terms of the climate change, ozone depletion, human toxicity, photochemical oxidation, particulate matter, ionizing radiation, terrestrial acidification, fresh water, marine, terrestrial ecosystems. There are a lot of others like fossil depletion, metal depletion, water depletion, all those things are there. And these are some of these stuff in terms of NRPAX per pallet, mechanical sorting device, hard plastics in MSW, metals in MSW. So for the different of the material present, so you see those impact coming from the individual categories. So the most, if you look at the most predominant ones, it is the truck transport. This is one of the truck transport is one of the main category that we see is the truck transport part. Again, transport comes out to be the major contributor. So in terms of the impact that is coming for all these different categories. So this was for NRPAX. Similarly, if you go for the coal, again different activities associated with the coal. Here again the yellow, which is our hard coal mix at regional storage. So that's what comes out to be the dominating one. The pink one is the bitumen at refinery, and so those are the because you need that for the transportation again, for in terms of the coal production. For incineration, here again we see the light green color seems to be dominating in many of them. It's our truck transport is very common. Then organic waste also is it's one of the dominating criteria here. So it's so in terms of these are again different impact categories, contribution towards different impact categories by different activities. So that's what you are getting over there. So in terms of the environmental impact assessment, if you look at the different criteria that we had, I'm sorry you cannot really probably read this slide very well, but I will just explain it. That again here, for one here on the right hand side, I have the legend for that. We have dark blue is the total NRPAX, the magenta color is MSW, green is incineration, and then we have another like the purple is the total coal, and the light blue one, which is the last column is the Dongera impact. So that's in terms of what is the different impact coming in. And for the ones which has 100%, we have which has the highest one, we put them as 100%, and the other values are with respect to those 100%. And at the bottom here are all the different impact categories, and here you see 0 to 100%. So if you look at these different categories, the Dongera impact seems to be much low in terms of most of the impact categories. The ones which is mostly high is the total incineration, and in some cases we see total NRPAX is also pretty high as well. So that's in terms of the environmental impact assessment. But if you look at the individually in terms of their impact on climate change, so incineration and coal is incineration is this part, and we have Dongera is over here. Similarly, in terms of impact on urban land occupation, again you see a lot of impact on coming from other category as opposed to what you see from the Dongera. Impact on marine ecotoxicity, impact on marine eutrophication. So we can look at all these different impacts individually as well. So what you saw in this particular graph over here was a combination of all different impacts together. Then in this these slides we are looking at individually their impact. So that is the individually how the impact is showing up. So again, for the different categories out there, you can plot them up, different categories. And so in terms of summary, what we found that in this NRPAX has a less impact on environment than coal for most of the impact categories. It has a better impact on environment than incineration. Most sensitive impact categories were climate change and the marine ecotoxicity, marine eutrophication, ionizing radiation, and terrestrial ecotoxicity. Major contribution were from electrical uses, disposal of plastics, organic waste, and metal. So these were the major contributor towards in terms of the environmental impact. So in somehow we can come up with a better electricity uses, more electrical efficient technologies, or if we can use better source of energy, then our results will improve in terms of the environmental impact. So conclusions were NRPAX was found to be environmentally positive substitute for medium grade coal. Actually it has lesser environmental footprint than medium grade coal, and it's a possible alternative treatment of MSW instead of incineration. So it even comes out better than the incineration plant. But of course there are a room for improvement. So according to the results, we found the energy usage reduction in energy usage. If we can do that, energy audit can be done to look at an inefficiency in the production process. So that will be another thing can be done. Leachate that is generated due to landfilling of rejected plastics. So Dongera may want to consider collection and recycle of plastic. If we can do the collection and recycling of plastic by the same plant, that may help because they don't have to send it to a long distance. They can do it in the same campus within the same area. And if we can put some renewable energy sources like solar panels to supplement the required energy. This plant has a huge footprint, so they can put some solar panels, and then if you can use some of those solar panels for that. So that's kind of just again give you an example of it's in terms of how this LCA activity is used in a practical sense. So this was a practical problem where the company really wanted to do this LCA so that they did take this results and present it to MO, Ministry of Environment, and the student and myself were there with when we had the meeting with Ministry of Environment, and then there were certain relaxations given to the company. So again, you have to this is what you will do if you really want to use this LCA toward later on in your professional life. These kind of scenarios you will be where certain companies are trying to make some decision, and this LCA tool help them make the decision, or they are using this LCA tool to present their case to a regulator, which was the case over here, where the regulator took the decision based on the data that was presented. And since it was done at a university setting, it was a master's thesis, a university student and a faculty were involved, they adds a little bit of credibility to the study in terms of non-biasness and trying to have more independent study. So that's an example, and then we'll see a lot of examples like this in the last week. Last week we'll have a lot of case studies associated with this on this LCA exercise. So with that, we'll close this particular module, and then I'll again see you in the next module. Thank you.